Question number 19, we're given an equation and we're asked what is the effect of increasing the temperature. So notice that this is a system at equilibrium. So it initially has a seesaw that is even. But if I increase the temperature, notice that heat is here on the reactant side. So if I increase something on this side, my seesaw will tip this way. Recall that equilibrium shifts towards the upside. So in this case, equilibrium is going to shift to the right. And recall that the concentrations of everything on the lower part of the seesaw goes down, and on the upper part of the seesaw goes up. So in this case, you can see that our product, which will be here on the right side, is going up. So question number 20 is just looking at why temperature makes a reaction faster. That's because temperature is directly related to kinetic energy, so it increases the frequency and effectiveness of the collisions. Question number 21 is again looking at the effect of heat. Now here we initially begin with a balanced chemical reaction. Recall that the fulcrum of our seesaw always lines up with our arrows so that the reactants are always on the left and the products are on the right. Here, heat is a reactant. That causes our seesaw to shift in this direction. So here, equilibrium shifts to the upside, which is right. Now, when equilibrium shifts to the right, remember everything on the left, all of the reactants concentrations will go down, and all of the products concentrations will go up. So our hydrogen iodide increases. Question number 22 is looking for the lowest entropy. Recall that entropy is randomness, so we're looking for the least randomly arranged particles. Now here, the only difference is the state of matter. So the least random state of matter is the solid state, as those particles are in regular fixed positions. For question number 23, we are looking for the formation of water from its elements. Notice, so we're going to form or produce water. Liquid water will be a product. So here on reference table E, we can see there's two reactions that have water as a product, but here we're looking for liquid water. So the reaction that forms liquid water is this one. When we see that, we can see that this is the corresponding delta H value. Since our delta H is negative, this is an exothermic process. Exothermic processes lose energy. So choice 1 is the best choice. Notice we are losing energy. Now recall that all potential energy diagrams must have an activation energy, an energy to get the reaction started. Choice 3 and 4, reactions with valleys, can never be the correct answer. In question number 24, we're given a system at equilibrium and basically asked to describe it. Recall that in equilibrium, the rates are equal and the concentrations are constant. In question number 25, we're looking at this potential energy diagram and trying to figure out if this is endo or exothermic. We can see that the energy is increasing or energy is going in. That means this is an endothermic process because energy is increasing. Now recall that adding catalysts to chemical reactions does not change the potential energy of the reactants or the products. But what it does do is it lowers the activation energy. Question number 26 looks at a system at equilibrium. That equilibrium, we'll assume again, it kind of is like a seesaw that is perfectly balanced. In part A, we're looking for what happens when we increase the temperature. Notice the temperature is a product. So if I increase something on this side of the seesaw will dip in this direction. So that means that equilibrium is going to shift to the upside, which is left. But what we're really looking for is what happens to the nitrogen. Since nitrogen is a reactant, its concentration will increase. Please, on your task, refrain from using simple arrows as up and down and write the words increase and decrease. The next question asks us to state the effect of the number of moles of hydrogen as the pressure of the system is increased. So recall that when we increase pressure, we're going to shift towards less moles to try and alleviate the pressure. So what we'll need to do is count the number of moles on the reactant and product sides first. To do that, we're going to sum the coefficients of the gaseous substances. So on the reactant side, we have 4 gaseous substances. And on the product side, we have 2 gaseous substances. So 2 is lower than 4. So when we increase pressure, we're going to favor the lower number, the 2. Recall that equilibrium shifts, if we draw a seesaw, to the upside. So we're going to make 2 up. In this case, we want to know what's happening to the hydrogen. Notice that hydrogen is a reactant. So our reactants are down and our products are up. So the hydrogen will decrease. Lastly, we're asked what will occur to the concentration of ammonia if a catalyst is added. Catalysts do not change equilibrium. They speed up both the forward and the reverse reaction equally. This concludes the review for the equilibrium and kinetics exam. Good luck.